Hello friends, welcome. In this session, let's look at one example related to the relation between the zeros and the coefficients of a cubic polynomial. So here is the problem. If the zeros of the polynomial 2x cube minus 15x square plus 37x minus 30 equal 30 are in arithmetic progression, find the zeros. So first let's try to recap and see what is the relation between the zeros and coefficients of a cubic polynomial. We'll just try to recap that. For that, let's write it down here. Suppose I have a cubic polynomial ax cube plus bx square plus cx plus d, then alpha, beta, gamma are the zeros of this cubic polynomial, then alpha plus beta plus gamma equal to minus b by a, then alpha beta plus beta gamma plus gamma alpha equal to c by a. Not only that, we have alpha beta gamma equal to minus d by a. How will you get this? Very simple. Take ax cube plus bx square plus cx plus d and write it as x minus alpha into x minus beta into x minus gamma, because you know alpha, beta, gamma are zeros. You equate the x cube, x square, x and constant terms, you will be getting all these relationships. That's how we can identify the relation between the zeros and coefficients of a cubic polynomial. Now let's leverage that and try to find out the zeros of this polynomial, taking into the consideration that alpha, beta, gamma are in arithmetic progression. So let's start now. First let's try to find out for 2x cube minus 15x square plus 37x minus 30, what is alpha plus beta plus gamma? Alpha plus beta plus gamma equal to minus of b by a, that's equal to 15 by 2, because ax cube plus bx square plus cx plus d. Similarly, alpha beta plus beta gamma plus gamma alpha equal to c by a, that's equal to 37 by 2. Not only that, we have alpha beta gamma equal to minus of d by a, b, c, d, minus of d by a, that's equal to 15. Now what we know that the zeros are in arithmetic progression. What's the meaning of that? If alpha, beta, gamma are in AP, then we know that beta minus alpha is equal to gamma minus beta, or nothing but beta equal to alpha plus gamma divided by 2. So we know this is the condition which we have to satisfy if alpha, beta, gamma are in arithmetic progression. Okay. Now let's leverage that and try to find out the values of alpha, beta, gamma. First we'll look into this one. We'll say alpha plus gamma plus beta equal to 15 by 2. Can I write beta as alpha plus gamma by 2? Just now we have seen that. So it will become alpha plus gamma by 2 is 3 by 2 into alpha plus gamma equal to 15 by 2. That gives me alpha plus gamma or gamma plus alpha equal to 5. So we know alpha plus gamma is 5 now. Alpha plus gamma is 5. So can we find out beta? Yes, we can find out beta. We will say alpha plus beta plus gamma equal to 15 by 2, and we know alpha plus gamma is 5, so I can say 5 plus beta equal to 15 by 2, or I can say beta equal to 5 by 2. Once I got beta equal to 5 by 2, I can go to the product and I can say alpha into gamma into 5 by 2 equal to 15, or can I say alpha into gamma equal to 6. We know alpha plus gamma is 5, and we also know alpha gamma is 6. This tells me that alpha equal to 3, gamma equal to 2. So the roots of, or the zeros of this polynomial are 2, 3 and 5 by 2. Let us check whether all the conditions are satisfied. You add all of them, 2 plus 3 5, 5 plus 5 by 2 15 by 2. You multiply them, 2 into 3 into 5 by 2 15. You just multiply them 2 at a time, 2 into 3 6, 3 into 5 by 2 15 by 2 plus 2 into 5 by 2 5, that is 11 plus 15 by 2, that's equal to 37 by 2. So the values what we got seems to be right. So let me just summarize before we close. If the zeros of the polynomial are in arithmetic progression, find the zeros. First what we will do, we know there is a relation between the zeros and the quotient, so let's try to leverage that. We have written here what is the relation between the zeros and the quotients. We know alpha plus beta plus gamma is minus b by a, alpha beta plus beta gamma plus gamma alpha is c by a, and alpha beta gamma is minus d by a. So we also know, since they are given in extra condition that they are in arithmetic progression, we know beta equal to alpha plus gamma divided by 2. Now we have leveraged that. The conditions what we have used only two conditions, first condition and the last condition. So we are able to find out the values of alpha beta gamma as 2, 3 and 5 by 2, which satisfies the condition that the zeros of the polynomial are in arithmetic progression. So I'll catch you again. Thanks for your time. Bye for now.